Hi guys, this is Mrs. Allison. You should have your note sheet that says notes solving radical equations and follow along with this video. Take notes and obviously pause, rewind as you need more time or just to review the concepts, but we're going to get started. Okay, so today we're going to talk about solving radical equations. So far we've really only just looked at simplifying radical expressions. But now we want to go into the idea of solving. And the idea of solving is actually not much different than any other solving equations that we've done. So if we want to think about how we have solved equations before, let's say, for example, I have something like let's start again. Let's say I have something like x plus 2 equals 5. How would I solve that? Think back to when you first started learning how to solve equations. Yes, we could figure this out pretty intuitively, but how can I go about solving it, going through the steps? Well, we know we would go through and we would subtract 2. Now, why would we subtract 2 when it says x plus 2? Because plus and minus, or adding and subtracting, undo each other. But we had to do it to both sides of the equation to keep it balanced. Remember, sometimes we drew that little line in and said, okay, visually what happens on one side has to happen on the other side. Okay, I'm going to erase this because I don't want it on here. We're going to do the same thing with solving equations. Now, the reason when the equation had an adding, we subtracted, or if it had a multiplying, we divided, is because those are called inverse operations. So to solve equations, we use inverse operations to undo something. So we're going to use that phrase undo here in just a minute. So to solve an equation, we use inverse operations to undo something. So for example, we just looked at one that if I have a positive, the inverse operation of that is the minus, the plus and the minus, the add and the subtract. So what about for multiplication? What's an inverse operation? Well, it's division. Okay, but we're talking about radicals. Remember, radicals means like the square root. We're only focusing on square root, although we could go further to cube root, fourth root, etc. We're looking at square root. So what undoes a square root? Well, the inverse operation of that is squaring. So if I want to undo a square root, I square it. Okay, so there are 3 types of equations that we're going to look at. The first one actually is, in my opinion, probably the easiest, is the 2 radical equation. Okay, so if we have 2 radicals in one equation, how do we go about solving it? Okay, there's 4 steps we're going to go through on almost all of these, and really the last 3 steps are the exact same for all of them. First step may start just a little bit different on each of them, but on a 2 radical equation, our goal is going to be to get it so that it is a radical equals another radical. Meaning I don't want 2 radicals on one side of the equation. I want to get it so it's radical equals radical, or square root equals square root. Okay, so let's look at what that might look like on this example just to the right. If we have the square root of 7x minus the square root of 6x plus 1, notice this has 2 radicals in this equation. Well, the first thing that I'm going to do is I'm going to get radical equals radical. To do that, I am going to add the square root of 6x plus 1. And remember, I can't do it just to one side of the equation. I have to add it to the other side. Okay, so to get it to be radical equals radical, I'm adding the square root of 6x plus 1 to both sides. So I get the square root of 7x equals the square root of 6x plus 1. Now I have it where I have a radical equals a radical. So in a 2 radical equation, we want radical equals radical. There's our first step. Okay. Our second step is the most basic that we've got, is to undo. I want to undo the radical. Well, how did we say we undo radicals? We square both sides. Okay, so I'm going to square both sides. Now, just so you don't get confused on the steps, I'm actually going to change the color of this just so you can see it a little bit different. So I am going to square the entire side. And when I square the entire side, what happens? Well, we know that a square root and a square undo each other. So what this looks like is this becomes just 7x equals 6x plus 1. Okay, so we've undone the square root. Well, this becomes an algebra problem we've been doing for a long time. So now my third step is to solve the radical equation. Okay, so solve it. To solve this, it's just algebra. So now I'm going to undo the different pieces. So I'm going to move the 6x over. So we get 1x equals positive 1, which is silly to write. We would probably just write x equals 1. But there's one other step that I want to go through with you on this, and I probably on my note sheet would do this to the right. I just didn't leave myself enough room on this screen. So I'm going to come over here to the left, and I'm going to check my work. So my last step is to check my work. Maybe not quite as important on these first two types of equations, but on the third type of equation, it becomes very important. Okay, so to check my work, here's what it's going to look like. I am going to plug in x equals 1 into my original equation. So I have 7 times 1, the square root of 7 times 1 times this, or minus the square root of 6 times 1 plus 1 equals 0. And I want to verify that this works. So I get the square root of 7 minus the square root of 6 plus 1 equals 0, which gives me the square root of 7 minus the square root of 7 equals 0. Is that a true statement? Sure. 0 equals 0 is a true statement. So I know x equals 1 is the solution. So I've gone through, I've gotten my radical equals a radical, I undid the radical, I solved, and I checked my work. So what I would like you to do is hit pause and try the next two examples and see how you do. All right, hopefully you had a chance to try these. So let's go through the steps. I noticed that this is a 2 radical equation again. So I've got the square root of x minus 6 minus the square root of 18 minus x. 2 radicals. And I know the first step is to get it to be radical equals radical. So the first thing I'm going to do is I'm going to add the square root of 18 minus x. But I have to do it to both sides. I can't just do it to one side. So we get the square root of x minus 6 equals the square root of 18 minus x. How'd you do so far? Okay. Second step is to undo. And I know to undo a radical, I'm going to square both sides. Okay. And in squaring both sides, undoing the radical, I get x minus 6 equals 18 minus x. And now I just need to solve the equation. So going through, I'm going to add x to both sides so that I can get all my x's on one side of the equation. 2x minus 6 equals 18. I'm going to add 6 to both sides. So we get 2x equals 24. And then I'm going to undo this by dividing by 2. So we get x equals 12. Okay. And my fourth step is just to check. So when I go through and check my work, I'm just going to come right here, see if I can squeeze it in and check my work. I get the square root of 12 minus 6 minus the square root of, notice I go back to the original, 18 minus 12, prove that that equals 0. So I get the square root of 6 minus the square root of 6 equals 0, which 0 equals 0 is a true statement. Perfect. How'd you do? All right, so let's try this next one. Notice in this next one, though, I can skip that first step. I don't have to get a radical equals radical because it's already there. Let's go through and draw a line in so we know where I'm going. Okay, and since that step's already done, I now need to undo the radical. So I'm going to square both sides. And what that leaves me with is 6x minus 1 equals 8x minus 1. And then I'm going to solve. Subtract 6x from both sides. So I get negative 1 equals 2x minus 1. Add 1. I don't think that's supposed to be a minus 1. I lost a sign in there. Shoot. What did the original problem say? 6x plus 1. This should have been a plus. Your note sheet has it correct, but this does not. So let's change that to a plus. So I have a positive 1 and a positive 1 equals 2. So 2 equals 2x. And then divide by 2 on both sides. So we get x equals 1. Okay, so now I'm going to go through and check my work again. And these can be quick mental checks if you would like. But 6 times 1 plus 1 equals the square root of 8 times 1 minus 1. So I get the square root of 6 plus 1 equals the square root of 8 minus 1. So I get the square root of 7 equals the square root of 7. And I don't need to go any further. That's a true statement. So I know my answer is x equals 1. How'd you do? Okay, well, you know it's going to get just a little more fun. So let's move on. Let's look at what happens now when we have a one radical equation. You can see the example to the right. I have the square root of 4 minus 7x plus 4. Notice the plus 4 is outside of that square root, equals 9. Okay. And remember, I said the first step is going to be a little bit different. So here we go. First step. My first step is to isolate the radical. Well, what does that mean? What does it mean to isolate? Right, it means to get it by itself. So we are going to get the square root alone, meaning on one side of the equal sign should be only the square root, nothing outside of it. Okay, so in this particular example to the right, I see that that plus 4 is what is keeping me from having the radical by itself, the square root by itself. So I'm going to get that by itself by subtracting 4 from both sides. And that gives me the square root of 4 minus 7x equals 5. Okay, first step. Well, the second step is not any different than before. So now I'm going to undo my radical. Same way I undid the radical before. To undo a square root, we square both sides. So I'm going to square both sides. And that leaves me with 4 minus 7x equals 25. So I've undone the radical. Now it's just a normal algebra equation. And so my third step is to solve. So I'm going to go through and solve this. Well, to solve this, I see that I'm going to get my x alone, so I'm going to subtract 4. We get negative 7x. Please, 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 please be careful. Bring down that negative. Negative 7x equals 21. Then dividing by negative 7, we get x equals negative 3. Okay, and the fourth step is still the same. We are going to go through and check our work. And again, if you get proficient at this, this is not one of the problems where we typically have an issue. We'll look at those in just a moment. So I'm just going to quickly check my work. I'm going to plug it into the original equation, meaning not one that I've changed, not one that I've squared, not one that I've done anything else with. So we have 4 minus 7 times negative 3. And then that gives me 4 plus 21 plus 4 equals 9. Square root of 25 plus 4 equals 9. Some of you might see it already. We know the square root of 25 is 5. And 5 plus 4 equals 9. So 9 equals 9, and that's a true statement. So I know my answer is x equals negative 3. All right, pause the video. See if you can try the next two and see how you do. And we'll come back and look at them together. All right, let's see how you did. So 4 steps. Isolate the radical, get it alone. Undo the radical, solve the equation, and then check our solution. So let's see how we do. In this first problem, notice that what's in the way of getting the radical by itself is this 3 outside. So you've got to ask yourself, how is the 3 attached to the square root? Well, we would read this 3 root, meaning there's no operation written in the middle, so what's implied? multiplication. So to undo multiplication, we are going to divide both sides by 3. So we get 4 equals the square root of negative 5 minus 3x. And now we have our radical by itself. So my next step is to undo the radical. So I'm going to square both sides. It's like my handwriting keeps getting larger and larger. Let's see if we can make this a little bit smaller now. So we get negative 5 minus 3x equals 16. Don't forget to square both sides. What's a little bit weird sometimes is when we square something that's a radical, it really doesn't look that different. Just the radical goes away. So we don't want to forget that this 4 didn't have a radical. So when I square it, it actually is 4 times 4, or 16. Okay, now let's go through and solve. So I'm going to add 5. And we get 21 equals negative 3x. Again, this is one of those problems where we need to make sure we remember to bring down that sign with it. And I'm going to divide both sides by negative 3. It's kind of funny, similar numbers to before. And we get x equals negative 7. So now let's check our work. When I check my work here, I'm going to go back to the original equation. 12 equals 3 times the square root of negative 5 minus 3 times negative 7. So we get 12 equals 3 times the square root of negative 5 plus 21, which gives me 3 times the square root of positive 16. We know the square root of positive 16 is 4. And 3 times 4 is 12, so we get 12 equals 12, which of course is a true statement. So then x equals negative 7. All right, so if you didn't quite get that one, maybe pause it now and see if you can get this next one. Otherwise, let's keep going. I'm going to undo the radical. We see that to undo this particular, I'm not either. I'm going to isolate the radical, and to get it by itself, I'm going to add 8 to both sides. So we get the square root of x minus 5 equals 1. Now I'm going to undo the radical. And so we get x minus 5, because it was the square root and we undid it with a square, equals 1. And then I'm going to add 5 to both sides to solve. So we get x equals 6. Okay. Let's check our work on this one. So, checking my work going back into the original problem, I get 6 minus 5 minus 8 equals negative 7. And the square root of 6 minus 5 is the square root of 1. And the square root of 1 is 1. So 1 minus 8 equals negative 7. Negative 7 equals negative 7 is a true statement. So x equals 6 is my answer. How'd you do? Okay, well, let's make it just a little bit more fun. Our final type of equation, radical equation, is when we have one radical still, but this time it equals a variable. So far we haven't looked at what happens when it equals a variable, and it does change a few things. Okay, so the 4 steps we're going to go through actually are going to look very similar, but I'm going to add a few phrases to the 4 steps that are going to help clarify it just a little bit. Okay, and I kind of think I maybe didn't leave myself enough room on this slide. So hold on, I'm going to change it just a little bit. Okay, I just removed the problem. I put it on the second slide. So we have a little bit more room to write. Okay, 4 steps. First step, because it's a one radical equation, I am going to isolate the radical again. And then I'm going to undo the radical. Here's where it's going to change just a little bit. The next step was to solve. So that hasn't changed. It's still going to be to solve. However, in solving this at this point, usually we are going to need to factor. So I'm going to put usually factor. Oftentimes, because if it's equal to a variable, we will get a squared term on one side, an x squared term, which typically means we need to factor something. Now what I'm going to do is my 4th step and final step is I'm going to check. And this is the time where it becomes more important to check, because we will get something called extraneous. Look at the root word of this, extraneous solutions. Okay, so when you hear that phrase extraneous, look at the root word, it's extra. Okay, so I will end up getting extra solutions. Sometimes they both work, sometimes they do not, and that's something we need to check. Okay, let's go through an example. Here we go. We have the equation x equals the square root of negative 30 plus 11x. Okay, well, the radical's already by itself because there's nothing multiplied by this radical. There's nothing added or subtracted afterwards. So this radical is isolated, so that part's done. So I'm going to undo the radical by squaring both sides. Okay, notice that I get x squared equals negative 30 plus 11x. Do you notice it's a quadratic? Okay, do you see that? How do we know it's a quadratic? How do we know we're going to need to factor? Remember, we've talked about that if I have an x squared term and an x term in the same problem, the only way I can solve it is by factoring. So I really now need to try to factor this. So I'm going to remember my rules of factoring is that it needs to equal 0. So I'm going to start by moving my 11x over, which would give me x squared minus 11x equals negative 30, but I want it to equal 0, so I'm actually going to add my 30 over. And because none of these are like terms, I can't actually combine them. So I get x squared minus 11x plus 30 equals 0. Okay. Now I'm going to go through and factor. I'm going to notice there's no greatest common factor, but I do notice it's a trinomial where the a is 1. You can use Xbox. You can just use the idea of guess and check, meaning I'm looking for two numbers that multiply to 30 that add to negative 11. So to multiply to a positive number but add to a negative number, they both need to be negative. And so I'm going to do x minus 5, x minus 6 equals 0. And then I have the zero product property, which says that x minus 5 equals 0 and x minus 6 equals 0. And if you need a reminder on how to solve by factoring, go back to Unit 6 in my website. There's a video called Solve by Factoring, so you can refresh your memory. Now I'm going to go through and solve this. So when I undo the negative 5, I get x equals positive 5. And x equals positive 6. So I believe I have two solutions, and I believe they're positive 5 and positive 6. But I'm going to check my work. And when we check our work on this one, I need to check both separately. So let's start with the 5. Is 5 equal to the square root of negative 30 plus 11 times 5? Notice I'm substituting in 5 every place there was an x in the equation. Okay, so now I'm going to go through and solve. So we get 5 equals the square root of, and notice I'm not solving that by squaring. I'm just simplifying both sides. Okay, so we get 5 equals the square root of 25. Is that a true statement? Well, yeah, we know the square root of 25 is 5. So 5 equals 5 is true. So I know x equals 5 is a good solution. Okay, let's try the next one. X equals 6. I'm going to come down just a little bit. So is 6 equal to the square root of negative 30 plus 11 times 6? Is 6 equal to the square root of negative 30 plus 66? Is 6 equal to the square root of 36? Square root of 36 is 6, so 6 does equal 6. And in this case, both answers work. Okay. Pause the video. Try the next one. See how you do. Okay. Hopefully you had a chance to try this one. I noticed that my radical is already by itself. It's isolated. So my first step, again, is going to be to undo the radical. And when I undo this radical, I get I get 72 minus x equals x squared. Again, you should notice I have a squared term, a single x term, which means factoring. Most of the time, that's going to be the case when it's one radical equals a variable. So I'm going to move my terms over, switch to the pencil. So I'm going to move my terms over to the other side. So we get 72 equals x squared plus x. You may ask why I'm not moving the x squared. Remember, when we are solving by factoring, we want the squared term to be positive. Okay, so that's why I'm moving all of this, even though it's two terms versus one. I'm moving these over so x squared stays positive. Okay, let's keep going. So I'm going to subtract 72, and I get 0 equals x squared plus x minus 72. Now to factor. I notice that it is a trinomial where a is 1. And so if this is the case, when I solve this, I can factor this. I can multiply x times positive 9 and minus 8, because positive 9 and negative 8 multiply to negative 72. And then positive 9 and negative 8 add to 1. So using the zero product property, we get x plus 9 equals 0. X minus 8 equals 0, which means we get x equals negative 9 and x equals positive 8 when I solve. So now let's check our work. And let's start with that first one, x equals negative 9. So is the square root of 72 minus negative 9 equal to negative 9? Notice I'm just replacing the x with what we think x equals. Is the square root of, this will end up being a positive 9. So 72 plus 9 is 81. So the square root of 81 equal to negative 9. Square root of 81 is 9. Is 9 equal to negative 9? No. 9's not equal to negative 9. This is not a true statement. Therefore, x equals negative 9 is one of my extraneous, you'll often see it abbreviated EXT, extraneous solutions. It doesn't work. Well, let's check the other one just to make sure. Square root of 72 minus 8, it is possible to have no solution. 72 minus 8 is 64. Is the square root of 64 equal to 8? Well, the square root of 64 is 8, and 8 is equal to 8. So this is true. So my one solution here happens to be x equals 8. Okay. So there's our final answer. Feel free to rewind the video, rewatch whatever you need to, and we'll see you in the next video.